So hopefully that's going.
Okay, perfect.
Yes, it's recording. Okay, so let me go to the front page. So welcome everybody to this ODPi webinar. My name's Mandy Chessell. I do work for IBM, but in this case, I'm representing the ODPi's data governance PMC. And I'd like to talk to you about some work that's going on in an open source project called Apache Atlas to create a metadata integration capability that's based on open standards and that is designed to enable technology from different vendors that works with data and basically stores and uses metadata to work together and actually exchange that metadata. Now this technology, although we call this a standard, it is actually it's not just a document. It's actually an implementation of the standards, and it's been written using a set of frameworks that mean that when a particular vendor integrates into this ecosystem, they actually have to write small components that translate between the format of their products metadata to the open format, and then it's pushed out into the open technology, and which then manages the transfer and exchange of that metadata. So the aim is that the Apache Atlas technology does most of the heavy lifting in terms of ensuring that metadata is exchanged with integrity. So today I'm going to talk a little bit about the standards and how they work and why they work the way they do, to give you a feel for the type of work that's involved in integrating into this ecosystem. So I thought it's just a little bit about me. I thought I'd talk about, why are we doing this? Why is this so important to vendors to be a part of this ecosystem? The types of technology we expect to use we use the open metadata technology, different ways of integrating into the ecosystem, how we've implemented the reference implementation that you would download and use for your product, and then the different mechanisms for integrating into the ecosystem. I'm very happy to take questions at any time. You can use the chat, you can interrupt me. This is designed to be, an information exchange. So, questions are welcome at any time, but there will be time at the end for questions too. Now, if we think about sort of why are we doing this, if you think back to the time when we used film and we processed photographs and they were printed on paper, it was very often we lost track of what this photograph was about unless someone had been very kind to write on the back, who it was, where it occurred, and things like that. Nowadays, with modern cameras, with digital cameras, a lot of information about the photograph is captured automatically, and it's stored with the photo, and so that we can take photographs taken at different times and actually use the metadata to compare how a location is changing over time. So this metadata makes that photograph significantly more useful for processing, because we understand a little bit about the situation in which the photograph was taken. The other thing that's good about digital photographs is you're not restricted to a photo library program to manage these photographs provided by the camera manufacturer. You're not locked into their ecosystem because it's an open standard. You can take your photographs and upload them to photo libraries from many different vendors. You can then add to it and use them in whatever way you want. So this is an example of the type of metadata management we want to achieve for all data. So we're looking very much at automation. How do we automate the capture of metadata as data is created, particularly about the context of that data? How do we make sure we can transport it between tools provided by different vendors? How do we make sure we can augment it in standard ways that augmentation actually can also be sent between it? So that's the ecosystem we want to build. Now, anybody who's had any experience with the types of data that many organisations have, it's a lot more complicated than just photographs. Much of the data is managed by bespoke applications in its own format. There's very little metadata support in most of the tools, and where it occurs, that metadata is stored in a proprietary metadata repository in a proprietary format, and often can only be accessed through the tools from that vendor. So, so even though everything we want to do with data, from analytics to graphs and reports and demonstrating compliance, all these things that we need to do with data, you know, is required by every organisation. We actually don't have a good solution that allows an organisation to buy tools from the vendor of their choice, and in fact, and then combine them and have them work together. And that's the goal of our project. So this is just a picture of what typically organisations have. So they might have multiple tools, each with their own metadata repository represented by the blue cylinders. And the metadata that's in them is just basically what the users of that tool have loaded. So none of the tools have an enterprise view of the data. Different policies might be being used through different tools, and there's a huge cost in maintaining the metadata in each repository. This makes it expensive to bring in a new tool, and when a new tool comes in, it comes in empty, so it takes a while before that tool can start to deliver value. So what we're trying to do, I think is the next chart, yeah, we're focused very much on, as I say, automation, making sure that metadata management is available everywhere, so that tools that are working with data expect and produce metadata accordingly. We have to make it open. We have to make sure that the metadata can be accessible from different tools so that tools can share metadata. And we want to use metadata to drive the governance of data. So that means we need to be able to push it right into the operational environment that's managing security and protection and data quality and all the things that you would expect with an information governance program. And so all of this speaks to we have to have open standards and open implementations of those standards. And we don't believe in a single central repository. We still see that different vendors will have their own repositories. They will have tools that add value, that deliver specific value to organizations. So what we want to do is make sure that these repositories can exchange metadata, but it has to be peer-to-peer. We can't have any one repository being in charge. We don't have a philosophy that you load it all into mine and you know, and I'll do everything. It's very much a peer-to-peer exchange. The way the protocol's designed is that there's no particular repository in charge. And the exchange is limited only to the capability of the receiving tool. So just a sort of high-level block. So here's an example of two metadata repositories. They both connect onto what we call, the marketing term is the Open Metadata Highway. And in its simplest form, you can think of that as a Kafka queue and a set of RESTful interfaces, so that the repositories can do metadata replication and also do direct queries between one another through the metadata highway. The code, I put Apache Atlas here, but Apache Atlas is just the code base. So it's the open source project that we're using to develop this code. And this code will run in the Apache Atlas server. You don't have to use the Apache Atlas server in order to use this capability. It's a set of libraries. It can be incorporated into different products, and it can also run as its own standalone server that your product integrates with, and then it acts as a proxy for you to the Open Metadata Highway. So we have this exchange, and we call these the repository services that allow the metadata repositories to talk to one another. That's that one. And then we also have many APIs, and you'll see how many there are, that are designed specifically for different classes of data tools and engines. So there's an API for managing data protection, there's one for managing an asset catalog, there's one for managing access to BI tools, there's one for data processing, data movement engines like ETL tools. There's one for, I was trying to think, there's one for owners of assets. So basically there's a huge range of services that are specialized for a particular job. So again, vendors of those particular types of tools have a very natural interface to integrate into the ecosystem. That interface is provided by one of the open metadata repositories or by the Apache Atlas libraries, and they will then route the metadata to an appropriate repository. And there are rules as to where updates can happen and what can be replicated between repositories, and there's a security model on top of it. So how could we use this? Here we have a person from Human Resources, and they have some payroll data. And they need to they basically want a new model, a new analysis model for that data, so that they can keep an eye on parity of pay or whatever around for all their employees. The problem is that, of course, this data is very sensitive. It includes people's annual salary and their bonuses. And the person building the model is an employee. So they know everybody on this list, and obviously would find it very interesting to understand everybody's salary. But really, she needs to be able to build the model without giving away the deep secrets, particularly since she's in the data as well. So we need a way for the security engines to be able to understand where the sensitive data is located and mask it out accordingly. So in the metadata, think about what we know. At the bottom here is the actual data. Oops, got it the wrong way. Next, we have the database schema. So say this is in a database, we might start to understand the record structures by pulling the database schema. But we might not really understand exactly what job code means or whatever. And sometimes the column names are very obscure and quite difficult for business people to understand. So we then build a layer on top, which basically links the columns to meaningful names and descriptions about, from the business perspective, this is what these column names mean. And then we can get really fancy in the metadata by building a sort of ontology-like set of relationships on top that start to show how these elements relate to one another. So sort of employee name, employee ID are generally part of an employee description. And here we also have compensation plan that shows two alternatives of the annual salary and the weekly salary. And we can then take these definitions and add security tags on it. So providing the security engine, we're able to get this information to the security engine, it should know that 45324 is actually some sensitive data because it's basically part of a compensation plan. This is what we're building in the metadata. It can be presented to business users so they can sign it off to say, yes, we agree that compensation plans are sensitive. But then we push that metadata deeply into the runtime environment, and that runtime environment uses the metadata to make decisions. And if we then decide that work location is sensitive, we change the metadata repository to make work location sensitive. That is then pushed out to the runtime engines through those APIs I showed you before, and of course the right action happens on that data. So the business is very much in control of how data is being processed, and the underlying IT infrastructure just has to maintain the cache of the metadata and use it in its operation. So that's the goal. This is what we're trying to get to. So here's an example. It's actually our MVP, which when you actually see the size of it, you realize it's a very big MVP, but because we're trying to show the different types of integration, and the devil is always in the detail, we've actually got quite a comprehensive MVP in our work. So basically, we have a metadata repository. It happens to come from IBM, but it could be anyone that allows the definition of policies. Those policies are translated into the open metadata ecosystem, and then another metadata repository. And here we've got Apache Atlas, the Apache Atlas server running, And it's responsible, so it's running in the company's data lake, and it's responsible for actually managing the operational environment. So it's talking to things like Apache Ranger, which is a security engine, and the data virtualization tool that's being used. And the data virtualization tool is being configured to take those column names and put glossary terms, those nice business terms in place so that the business user can see it. And also the Apache Ranger plugin is being configured to control security. So here we have tools from different vendors being connected together through the open APIs to allow a business person to control exactly what happens in the operational environment. So that's the type of pattern that we're trying to enable, but for many different types of data scenarios. Now, when you start to look at what do people want for metadata, it does depend on who they are in terms of what they ask for. So here's Callie, she wants to be able to find data, understand it, and manage her models. Jules is a chief data officer. He wants to build the data strategy, to find the program that supports it, and then monitor how well everyone's doing. Faith, HR, she wants to be able to find the personal data, ensure it's properly protected, and understand the needs of the employees in the organization. Gary's in IT. He wants to make sure his infrastructure is safe and that things are being deployed and properly protecting data. So you can see they each have different goals. And if you just focused on one particular type of user, you'd have a specific definition of the metadata you need. And it goes on. So what we've been doing is looking at different scenarios, different users, different products, and saying what needs to be in that central cloud. And so we've come up with this picture here. So in the center is a definition of all the different types of metadata that people need. And then around the outside are these specialist APIs for different tools. So subject area is for tools that define glossaries and ontologies, basically the semantic descriptions of data. Information view, next one along, is for BI tools and for tools that support data virtualization, allowing them to maintain metadata about the views in their configuration. Asset catalog is for finding metadata. Asset owner is for managing, is for the governance responsibilities of somebody who owns a particular data asset. And it goes on, and I'll go into a little bit more detail about these. So each of these interfaces have been designed based on use cases from many different organizations. And then we've taken the superset of these and built a model in the center. And I think that's coming up next, yes. So I'm going to talk about what's in that model and how it's supported. Then I'm going to talk about the repository services that allow two repositories to talk together. And then I'm going to talk about the access APIs and how they look in comparison to repository services. And the aim of this is to give you an idea of what it takes to actually integrate into the ecosystem. So let me move on. So let's look at the types themselves. And that was the picture I've shown you already. So what goes in the middle? Basically, when you break it down, there are 8 major subject areas of metadata. There's the core one, which is, these are the data assets. And when we mean data assets, we do mean data stores, data sets, API payloads. So APIs are very important because they're passing data across it, and events as well, also important. So we're looking at data in its broadest sense and how it flows and moves around and is processed in the organization. So the data assets also do include analytic models and software processes transformations that move data around. So it's anything that, that is related to data. We need to know about the infrastructure that those assets are working on, so we can make sure that sensitive data is on encrypted platforms and things like that, and understand the exposure of different assets based on the infrastructure that supports them. So that's the yellow area at the bottom there. Above it is lineage. So this tells us where these data assets came from and the processing that was done in order to produce them. The governance area describes the data strategy, the governance program, the terms and conditions and rights management associated with data assets and classifications, and the rules that are associated with each of those classifications. So this describes the rules around using the data assets. The glossary, center at the top, that is the semantic description. So that's the glossary terms that I showed you in the earlier example. Collaboration is who's using it, their feedback, comments, tags, star ratings, likes, etc. So if you imagine you've got a community of data scientists working, as they're working with the assets, they can post different types of feedback. That's available to the team working with the data, but it's also available to the asset owner, so they can see how people are working with their asset. Any quality concerns will all come back to them, so they can see the feedback. So then we've got models and reference data. So these provide common structures and code values related to the data, and that's very important for developers working on new capability, maybe new data stores, new APIs and things, to actually have common structures that they can work with as they build new capability. And finally, metadata discovery is information discovered through automated processes that provide additional information about the data assets. And so we basically create annotations that are attached to the data assets that can then be assessed by the asset owner or the steward associated with it, and then maybe turned into a more formal definition. So that's the metadata discovery. So it's a very comprehensive view, and we're interested in covering the development lifecycle around the IC that supports data, the DevOps pipelines that deploy that capability into the operational environment, the way that infrastructure is managed from an IT perspective, and then also the way the business is using and controlling that data as they go through. So the aim is to really cover the complete life cycle of the data. And this next picture is just the next level of detail. If you go to the Atlas Wiki, this picture's there, but you can also drill down and actually look at the specific classes, relationships, the attributes associated with it that we've implemented in the open metadata libraries. Okay, so how does this work inside? We've got all those types, actually 351 types, and we need to basically have a way of supporting them, understanding that this metadata is distributed across many different systems. And the way we operate is to have a meta model, concept model you could think of, that is actually very simple. So it talks about entities, things. So a glossary term is an entity, a column in a table is an entity. So these are the things that we want to talk about. The classifications are tags effectively, so sensitive data, that's a classification. This project is for governance. This project is for building a new data warehouse or whatever. So we can basically take the objects that we're collecting and we can classify them into groups. And when you classify things, you can then manage them once you understand what you have. Then the third thing we have are what are called relationships. So relationships basically link two things together. So you can say, this classification has these rules associated with it. This database column has this glossary term associated with it. So you have ways of relating things. And the interesting thing is that in this model, classifications, the entities and the relationships can all have attributes or properties associated with them. So when we're looking at a relationship, we can say when it was established, how confident we were, who was the steward involved. A classification can actually say, we can classify something as having a managed retention period, and then we can actually put the date that it should expire in the attribute. So this gives us a lot of power in terms of creating some initial information that we might get from a specific data platform. And then through various processes and people's expertise and the types of tools that are going on, we can start to add more and more information to the model. And the way that we store relationships means that basically the relationship is stored independently of the entity, but with references to the entity that's a part of it. So we could actually store two entities, each in different servers, and put the relationship between them in a third server through the open ecosystem. And again, that helps where you've got different repositories that support different types of things. Then we build our model, and that was the colourful picture I showed you before. But if you look at these boxes, they describe each of the different concepts and the attributes inside it. But if you look at the tiny words, you can see, oh, that's a relationship, that's an entity. So referenceable is an entity. Semantic assignment is a relationship. So these actually show what type of thing the different definitions or types, as we call them, are implemented. And this is what you'll see on the wiki if you look at it. So this is the wiki and this is the link to it. So if you're interested in exactly what we store, then that's available there. Now, we almost have this gives us a language to store and exchange metadata in. The repository services are responsible for the movement of metadata between different repositories. So it supports federated queries. So one repository can issue a request and that request will be routed to all the connected repositories and the response assembled. It supports replication of metadata. So it might be that some metadata elements are managed in one server but used continuously by all the others. And so we might replicate that metadata for performance or availability reasons. And the third is a sort of on-demand query of metadata between it. And that's all supported by the repository services. And sort of here's the layout of the server inside. So the top, the access services, these are the specialist services for the different types of tools, the colorful things. Then this is the repository services that do this exchange. And then underneath it is another important aspect of the technology, in that every single external resource that we use is accessed through a connector. And these connectors, the implementations can be changed, and they're basically configured into the server. So we can change, say here we've got an audit log connector. So it could be writing to a file, or it could be being routed to a central systems administration system. You know, they're all multiple places. So there's a lot of flexibility in how this technology runs, and it can, through the connector framework, it can be deployed in many different environments, and that's a deliberate policy to allow it to be used by different vendors for different environments. So that's the basic structure. Inside the repository services, there are four main components. The enterprise repository services are the ones that do the federation. So they make the collection of metadata repositories that are connected together, and we call that a cohort, look like one repository. So when the access services connect to their local repository services, it looks like they've just got one big database, and they can work with it. They'll get events from that database, and they also have an API. Under the covers, the enterprise repository services are working with a local repository, which is the repository supported by the actual vendor tool, and then the cohort services that do the communication with the other repositories. And obviously there's an administration piece that controls the configuration, because any one of these three, the enterprise, local, and cohort services, they can be turned off or on in different combinations, and that's controlled by administration. That's the server. Oh, there's two APIs we've got. The OMAS administration services are the APIs to configure the server, and the OMRS REST APIs is the APIs used to communicate and issue queries between the different repositories. That's the basic server. And then it supports, because you can turn different parts off and on, and because of the connectors underneath, we support different things for vendors to choose. So caller is where the vendor just uses the access services. They don't have their own repository. They just call in, and their requests are routed to all the connected repositories. Native is where a product has taken the open metadata library from Apache Atlas and basically embedded it into their product. And then thirdly, the adapter process, which I'll probably spend most time on, is where you actually run what we call a proxy server, which is provided by the open metadata technology. And inside it, you plug in two types of connectors. One that translates open metadata APIs into the vendor APIs, and the other is called the event mapper connector that takes events from the vendor repository and turns them into open metadata events. So that's the three main patterns. And there's just a little bit more detail. So I mean, this one's very simple. The caller, we just use the appropriate access service API, and it takes care of actually finding the metadata, the right metadata repository, and using it on behalf of the tool. Here's the adapter. So this green box here, the repository proxy, is actually a server provided by Apache Atlas that supports the open metadata repository services. And you can see the purple box. That's the vendor tool that is working with working on providing the both the API and the event exchange between the vendor product and the repository proxy. And these two plug-in components, the repository connector and the event mapper, are what you would need to write to incorporate a particular tool into this ecosystem if you're connecting at the repository layer. And then finally, the native pattern is you take the repositories, put them inside your server, and so you then have access to the APIs and the function that is provided by the open metadata repository. You can have your own metadata store implementation that's easily plugged in, plus all the other connectors can be changed to match into your particular environment. And the only restriction you have here is that those services are all written in Java, so you really need a Java to be able to host a Java environment. And so lots of different products can connect in to the metadata highway using their own choice of pattern. And actually, it makes no difference to the quality of the interaction that they have with the others. So none of the communicating products know what pattern the other one's using or are impacted by those choices. Now, I talked about the idea of a cohort. And a cohort is a collection of repositories that have been configured to work together. And I said before, this is a peer-to-peer protocol. So effectively what happens is we create a topic, so say a Kafka event topic, and they all report about this topic. So they all have access to the topic. And that's effectively the only shared resource. And when they start up, they're given the topic name and they register. And I'll show you how this exchange works. And that registration passes everything they need to do RESTful calls, message exchange, and negotiation about what is actually being shared across the cohort. And that's basically just by connecting in, any one of these products will be able to see the metadata of the others, security allowing. But in principle, basically, that means that this metadata is being shared. So you might have the Chief Data Officer's tool defining the governance program, the data lake supporting a very large collection of data assets, and a hello, is that a question?
उसमें मेरे को तो लगाया मैनेजर सैंक्शन और उसको लगाया मैनेजर मॉनिटरिंग किसको सदीप को मतलब मैं sanction कराया करूँगा, वो monitor कराया करेगा.
There's quite a few people talking, so I'm just muting people. So if you suddenly discover you've been muted, it's because we were getting some noise over the line. So anyhow, so in this picture, and then we've got, maybe there's an ETL tool that is pulling data from systems of record that has, that also has lineage information that can be shared with the cohort. So that's one setup. It might be, if you're a bigger company, you might want to have multiple cohorts, and particular repositories can connect into as many cohorts as they like. There's no limit. And effectively what happens is, say, the data lake repository sees everything from cohort A, but the chief data office repository actually sees stuff both from cohort A and cohort B. And the access services and the tools connecting to that repository are completely unaware that it's actually coming from two cohorts. That's all handled seamlessly by the repository services. What's flowing between the on that Kafka queue, basically what the repositories exchange are three types of events. There's the registry events, which is how they exchange information about each other's configuration. The type def events is how they exchange information about the types that each support, because we don't expect repositories to support all types. They basically declare the subset of the types they support, and that's respected by the rest of the cohort. And then the instance events are the ones where we're actually exchanging specific pieces of metadata between the repository. And if we look at how that works, so here we've got the pink server, server 1, who's registering with the topic. And there's nobody else around, so that's as far as it goes. The pink server operates just as it would normally. Now the blue server, server 2, has come along and registered with the same topic. And so they do a registration exchange to exchange their configuration. And once that's complete, two things can happen. Firstly, when the tools issue metadata queries, they're automatically federated between the two servers. So the pink users start to see blue metadata and the blue users start to see pink metadata. So that's sort of a real-time querying of metadata from each server. And then, say, for example, so the blue server is the governance program server. You might have certain governance definitions that you use all the time. And so you might want a local cache copy. And so the repository services will automatically manage the caching and replication of updates between the two servers. And that's all controlled by rules in terms of what can be exchanged. And so it doesn't actually, the end users don't really see any difference, except for the fact that server 1 now doesn't have to go remotely to pick up the particular types of metadata that are being used all the time. So that's the exchange. And as I said before, the reference implementation that we've built is actually just a Java library. It provides support for a standalone server called the OMAS server that we use for the repository proxy, but you can actually configure it in different ways, put your own repository underneath it. So it provides a mechanism for, say, a new tool that's being built, new product, or supporting an existing ecosystem. We have the libraries embedded in the Apache Atlas server as well. So if you took the server out of Apache Atlas and you can run that standalone, it runs on the Janus Graph repository. So you can basically have that up and running, and that will give you the open metadata APIs plus additional value add that's been provided by the Apache Atlas community on top of the actual open metadata functionality. Now this is going into small letters, but I wanted to give you an idea of the types of interfaces that are provided, that need to be provided by a repository that wants to connect in. So I talked about two components, a repository connector and an event mapper. This is the interface of the repository connector. So there's the connector itself is quite simple. It's receiving information about the environment, the identifiers it's supposed to use, so that's quite a simple thing, but it has this method, get metadata collection, and that's shown on the right-hand side here. This object here is where the main work of the integration happens, and it defines all of the calls that are necessary for a repository to connect. And it starts with understanding the repository ID, and this is used for identifying who owns a particular metadata element. There's definitely how types are defined, the ability to retrieve entities, relationships, and classifications, the ability to add, update, and delete entities, relationships, and classifications. And then there are some advanced mechanisms for handling conflicts between members of a cohort. And finally, the ability to save cached copies or reference copies, as we call them, of metadata in each other's repository. So that's the API, and there is a set of definitions as to which ones are mandatory, which ones are optional, and how a repository connector responds to calls through its API in order to indicate what it can support and what it can't. So that's the repository connector, and then the event mapper is actually much simpler. So that's the thing that's receiving events from a particular tool and translating them into open metadata events. And so it has, they're both connectors, so they have a common set of methods, but it also gets things like repository helper, which provides a lot of methods for building entities, relationships, and classifications. The validator provides validation routines, and the repository event processor, so basically is the object that handles the events that you build. So basically you build, say you've got a message from your proprietary repository that says a new database column's been added. You build an entity that represents the database column, and you post it to the event processor, and it will do all the routing for you as part of the Is that a question? Okay, I'll keep going. So this workbook, which is available on our GitHub, takes those methods and actually talks about which ones are what they do and which ones are compulsory, which ones are optional. And actually, it's available for comment. So if you're thinking of integrating, please have a look at the workbook. And I would really love some feedback and thought about what we could do to make it easier, whether it's reasonable in terms of what we've put as mandatory versus optional. And so the more help we have with this, the more likely we're then to get it right. Now, that was the repository services, and that is the most complex way to integrate into this ecosystem. And you really need a metadata repository that's fairly sophisticated to be able to do that integration. However, we do have these access services, and every access service, as I say, is specialized, but it also supports both the REST API and the ability to integrate through topics, so asynchronous integration, so basically message-oriented integration. And so these APIs, they're not only much narrower, but they work on big objects. You can think of the exchange at the repository layer as being like atoms being exchanged, and at the OMAS, this access service layer, it's more like molecules. So you'll get much bigger and more comprehensive objects exchanged at this level that are related to the actual, the more concrete types, I would say. So here is a model that is a part of the actual metadata model that describes schemas, including database schemas and database type assets. So if you were integrating at the repository level, each one of these boxes would be sent to you as a separate event. And then you would, as you receive those, you would piece them together to basically build up the picture of this asset, which happens to be a database. It's got 3 database tables, and in each table are the following columns. So that's how that would be built up, and it's designed to be able to support very large tables and things like that, because it's then stuck across in tiny bits. When you look at an OMAS, an access service, what you get are consolidated and information that is all correlated together. So here, this is a connected asset OMAS, and there's a method called, say, get asset summary, and it will return. And you see the colours here. That reflects the different areas of metadata that was on the earlier diagram. You can see in order to describe this asset, we've pulled metadata from lots of different parts of the metadata repository and consolidated it together into a coherent object that can be returned and processed and displayed by the tool. And each of the OMASs do exactly this, but specialised for their particular consumer. So if you integrate with the OMASs, you're going to have very much more targeted, more richly structured information available to you. But as I say, it's limited and specialised to your particular tool. This colour coding here is showing where we are. So the work is an active project. We have a good sized team that's delivering stuff. So about 20 people working on the technology. The OMRS is getting pretty mature, still a few things to fix. And the access services are beginning to be rolled out. So the ones that are in the darker colour, asset owner, subject area, information view, these are all work in progress and are at different stages of completion. The ones in white are not started yet and beyond having a sort of high-level description of what they contain. So all of these, as I say, are open for collaboration, and that collaboration happens through the Apache Atlas project. However, technology isn't enough. So in Apache Atlas, we are focused very much on those access services, the repository services I talked about, and 2 new servers. And that's one of the things we're going to build this year. There's a stewardship server that is for handling workflow around things that occurred. Somebody asked for access permission, or there's a data quality problem, or something's been created without without something being done. When do we need a person to intervene? That's what the stewardship server is all about. And then the discovery server supports analytics and analysis of data items in an automated manner, so that we can dynamically create classifications and annotations on metadata. So, for example, a data platform detects that a new asset's been created. They inform Atlas. Atlas then kicks off a discovery pipeline. The discovery pipeline finds more information about that asset. Maybe it's detected a problem, and that then triggers an event in the stewardship server. So this is all the support that we're hoping to work on this year. And this will really start pushing the automation agenda. The business value comes from the support in the access services, and that's work in progress. And finally, the connectivity, which was our focus last year, is about how we share metadata with the different repositories. So this is what we're doing to Atlas. But again, there's an awful lot more to it, and this is where the ODPi comes in. We have a data governance PMC that's focused on adoption of the open metadata capability. And we're looking at providing best practices and content for people who are starting out on the governance journey. And that's developed by subject matter experts who are working through the data governance PMC to build these what we call content packs. And then we are looking to build workshops and compliance tests and things to help vendors adopt the technology and get the most value out of what's being delivered in Apache Atlas. And so both of these this work is being done through the data governance PMC. We have a wiki, and we also have a GitHub where the material is being gathered. And both of those links are there, including in GitHub are these charts that I've displayed today. So if you're interested in having a copy of the charts, please follow the link here to our GitHub and we'll be able to download them. So, how are we doing? We've got 5 minutes left. I've covered a huge amount of detail. Good job it's been recorded. And we can make that available. Does anybody have any questions? I'm going to unmute everybody, so hopefully it's not too noisy. But please feel free to ask any questions. Any questions, anybody? Okay. It's giving people a little bit more time to think of something. Any questions? Okay, well, thank you, everybody. I appreciate your attention. Please have a look at our content both on the Apache Atlas and the. Let me go back to that page so you can see it. Oh, one more thing. Sorry, almost forgot. We're doing another webinar in July, and this webinar is from our second part. So this was from the compliance team. This next webinar is going to be from our subject matter expert team, and it's going to be about managing privacy. So we're going to be building packs that can be loaded into the open metadata repositories and can help you manage privacy in your organization. So the aim is that we'll be doing one of these webinars probably once a quarter, alternating between looking at vendor adoption and then alternating with sort of enabling organizations to use this technology. So that's what we're doing, and I'll just take you back to the links in case you wanted to copy them down. That's it, May. I think we're done.